So I received a question about this problem, and I think it's a good one to go over together because I think it's kind of tricky. So according to a survey, 30% of residents of a country 25 years old or older have earned at least a bachelor's degree. You're performing a study and would like at least 10 people to have earned at least a bachelor's degree. How many residents of the country or 25 years or older do you expect to randomly select? Now keep in mind, I'm doing actually the example. Oops, I can't show it to you. So it's 6.2 number 53 from the study plan. I'm doing the example, but of course it's going to work very similarly to what the real problem is. It's just the numbers are going to be different. Okay, so 30% is our proportion, right? 30%. And we want our mean to be 10 because we want it to be at least 10. Okay, so we need to figure out how many residents to go randomly select. So let me bring up a sheet of paper here just to kind of look at it here. All right, so here it is. The mean is n times p. That's the formula for a binomial mean, and this is definitely binomial, right? P is 30%, and we need to figure out how many people we need to get. That's what we're trying to figure out, how many fixed trials we want. So you say, okay, look, if P is 0.30 and I want my mean, I want my expectation to be 10 people because I want at least 10. So then I need to poll at least, all right, now to get n by itself, we would divide by, oh here, I'll do it as another step. We would divide both sides by 0.30. So we need to divide by 0.30. Let me grab a calculator, hold on. Oops, there we go. All right, so notice that the 0.30 is going to divide away. Oops, and there's my calculator coming up, hold on. There it is. So I would do 10 divided by 0.3, and I would get 33.33333. So 33.3 repeating is equal to n. Okay? So we need at least that many people, I should say, because we want, let me be a little bit more clear about this. We want the mean to be at least 10, right? So if you really wanted to be really terrible about it, you could say, like, I want at least 10, so I really want this to be greater than or equal to 10. But we're not going to get too bent out of shape about that. Oops, I did that the wrong way. There it is. So technically we want, 34 or higher, or 33 or higher, but, it's fine. So we would probably have to round this up to the nearest person. Let me see how this goes. So do they round it? Because of course you can't really get 33.3 of a person. Yep, they rounded it. Oh, and I wanted to show you real quick. You could also do it with Excel. You just type equals 10 divided by 0.3. There you go. But we have to round it because you can't really pull 0.33333 repeating of a person. So, oops, let me bring this back up. So it's about 33.3, and then we would round that to, well, it's equal to 33.3 repeating. And then n is about 34. Okay? Now that's the easier part. Right there. Okay, so that's part A. There we go, I got that to work. Okay, so now, and again, we're being a little squishy because technically it should be just, at least 34, but it's fine. Now, B is going to be much trickier. So it says how many residents, let me see if I make, oh, yeah, I finished with that one, so we're good. All right, so now how many residents of the country 25 years or older would you have to randomly select to have a probability of 0.99 that the sample contains at least 10 who have earned a bachelor's degree, or who have earned at least a bachelor's degree? Now this is going to be much trickier. So let's think about this for a second. I want the probability of the probability that the sample contains at least 10. See that? Who have earned a bachelor's degree. Okay, so let me just write that out. I want the probability that the sample contains at least 10. So x is greater than or equal to 10 to be equal to 0.99, roughly. Let's see, to have a probability of 0.99. Okay. Now remember a couple things about binomial distributions. So, oops, let me bring my paper back up. Okay, so let me remind you of a couple things. So remember, binomial distributions always have x values equal to 0, 1, 2, 3, ... up until n. Okay, so if I want the probability, and let me make you a little well, that's fine. So if I want the probability that x is less than or equal to 10, or excuse me, greater than or equal to 10. So if I do this, I do the probability of x, okay? And this I'm just going to leave as a, hold on one second, let me do a table thing. There we go. Okay, so 0, let's see, 1, 2, 3, 4, 5, 6. Hold on, let me keep going. 7, 8, 9, 10. And then the kicker is it's 11 next, 12 next, and so on, dot, dot, dot. And we don't know where it ends. That's what we're looking for, right? Where does this end? What n value will make it so that this probabilities right here, well, actually, so that all of these probabilities right here have to add up. Have to add up to 1. So we want these probabilities to sum to 0.99. Okay? That's what they asked us for. Let me merge these cells real quick. Okay? So we want these green probabilities right here to all sum to 1. Or excuse me, not to 1, to 0.99. That's what they said they want. They said they want how many resonances have to do, so you're looking for n, to have the probability that at least 10 is 0.99. Okay, oopsie, back here. Okay, so I need these ones then to sum to about 0.01. Ah, okay, but luckily I can find these ones with a computer or a calculator pretty simply. Okay, these ones will add up using binom PDF, excuse me, binom CDF. Okay, so, and I'm going to do this a couple ways. I'll do it with both Excel and with a calculator if I've got time. Yeah, I got time. Okay, so let me do the calculator way. So the calculator way would be binom. Okay, if you want to find each one of them individually, you do PDF. You'd say ePDF, and then what you're going to do is you're going to fiddle around with it and find an n. Like, let's just say n is 40, just for the heck of it. And then you'd say 0. Oh, what was our probability? 0.30, comma, 9. All right, that would give you this individual probability. But I don't really want an individual probability. What I want is all of these ones put together. I'll make them yellow. Okay, so I want these probabilities summed up, added up. So let me, hold on, write this down. So then, note, and this is what we're writing in over here. So note, we want the probability of x is greater than or equal to 10. Okay. The probability that x is greater than or equal to 10 is 1 minus the probability that x is less than or equal to 9, right? That's what we just said right here. You want the green stuff, right? And there's tons of them in there. You know, hell, we even said 34 just for this part alone, right? So 12, 13, 14, 15, 16, 17, 18, 19, right? You want all of this to sum up to 0.99. Okay? That's what you want. Now, what you can do instead is, instead of finding what all these add up to, which would be really tedious, what you could do is find what these ones do, because these ones have to add up to 0.01. That way, when you subtract, you can get the 0.99. So if you want 0.99 over here, you got to have 1 minus 0.01 over here. So you need these yellow probabilities to add up to 0.01. All right. Now, if only we knew a way to find the probability of x is less than or equal to 9 quickly and simply. And the answer is we do. Okay, the probability that x is less than or equal to 9, which is what, it's the complement of what we actually want. There we go. Is equal to, and now it's different for the computer programs. So in the calculator, it's binom, I better write this out a different way. It's binom CDF, because you want to add them. CDF. Now you tell it the n, and here's the kicker. You're going to make stuff up. So n, but 0.3 is set, comma 9 is set, because we know we want it to be equal to 9. And what you do is you fiddle around with it until you find the one you want. So you go, okay, distribution menu, binom CDF is letter B on my calculator. Different calculators have it in different places. And you'd say, okay, I'm going to try 40. Let's try 40. So if I try 40 and I say 0.3 and I try 9, because I'm trying to get it to add up all these yellow probabilities up to 9 and including 9, I get 0.19. All right, that's no good. I need it to be 0.01, right? I need this to be equal to 0.01. So you try different values of n till you get the right one. That's it. It's a glorified guessing and checking. Yes, there are other ways to do it, but they're not worth your time. Okay? Oopsie. All right, so let's do it again. Let's try second enter. I'm just going to go back in here and try 50. Well, that's getting better. That's 0.04. All right, so let's do it again. Try 60. That's 0.005. That's too small. Okay, so 60 is too big, 50 is too small. So do it again, and you keep fiddling around in there until you find the one that's going to work, right? So you try 55. Getting there, getting close. That's 0.015. Okay, so let's do 57. There you go, 0.010. Let's try 58. Okay, that's too small. All right, so the closest one is 57. So through by trying different values, n is equal to 57 is the best. Best, not beast. All right, let me take a picture of it. Okay. Copy and paste. You can see it right there. The one that gets you 0.99 down here is the one that gets you 0.01 up here. So I have it so all of these ones are adding up to 0.01. Here, I'll merge the cells. I'm going to say these sum to 0.01. And we found that with binom CDF, comma, 57, comma, 0.3, comma, 9. So that's what these ones all add up to. And therefore, the complement, the green part, which is the part we were actually looking for, makes 0.99. At least 10. At least 10 is all this stuff down here. Okay? Now, with Excel, it's the same idea. You would just be doing a different function. In Excel, matter of fact, you can do it kind of simpler. You can say 0, 1, 2, and so on, right? So these would be your n values. You could just make them up. Like try n. Here, let me do it simply. So there's n. And then you're going to find the probability that x is less than or equal to 9 right here. So you'd say, okay, I'm going to try n as 40, just for the sake of it. I'm going to try equals binom dot dist, or dist, binom dist, if depending on where you're at with the old Excel versus the new Excel. 9, comma, your number of trials is that. Now use that cell reference. Don't do it by hand. Don't type 40. Use A2, comma, the probability of success was 0.3, comma, true. You're trying to get it to add up those probabilities. And you can see we got the same value that they got before. You can drag it down and just try different things. Like I try 50, I try 60, I try, oops, 60 is too much. I try 55, I try 57, and you can get the same answers that they got. And honestly, you don't have to drag it. You can just keep fiddling around with it yourself. Like I change this number to 22, I change it to 80, I change it to 50, right? You can fiddle around with just changing the numbers. You don't have to drag or anything. Same answer as the other as with the calculator. All right, I hope that helps with that one. It's a really kind of a tricky way to think about it. Oh, we better double check whether I'm right. Here we go. So they have kind of a by hand written thing there. And sure enough, oops, he said 58, so he rounded. Okay, so we'll round. So 0.01 was too low, so they went with this one. Okay, that makes sense because 0.0107 is just a little bit high. So I'll have to go with the 0.008. It's the first one that's below the value we really wanted. So let me go back to this, and we're going to make it 58. 58 is the best bet. Sorry, that was correct. I should have thought of that. Sorry about that. All right, I hope that helps.